So for the classwork activity on tessellations, you're going to go to modules. To unit 2 classwork tessellations. And this is due on Tuesday, March 28th. I'm going to give you till March 29th to complete it, but after that point, I'm not going to accept it because on the 30th, I am going to post videos on the tessellations page on answering which regular polygons actually tessellate and what other polygons tessellate. And you have to complete this activity before you watch that video, or because otherwise I give you all of the answers. So please complete this at the latest by March 29th. You may work in groups. So if you work in groups, that's fine. Just make sure you're including everyone's name on it and on the Jamboard. And then also there's one part that like each group member has to contribute to. And I'll show you that. So you're going to click on the Jamboard tessellations and make a copy. And you're also going to have to click on this link, the tessellation pattern blocks, okay, because you are going to use this to help you answer these questions. So you are going to make a tessellation, and there are only 3 regular tessellations. So there's only 3 regular polygons that tessellate. And as a group, you need to find which regular polygons tessellate. Okay, and so there's 3 rules for when polygons tessellate. The first one is the tessellation must tile a floor that goes on forever with no overlapping or gaps. The tiles must be regular polygons, so they're all the same. So remember, regular polygons are the angles are equal and the sides are equal. Okay, and rule number 3, each vertex must look the same. Remember, a vertex is where all the corners meet. So on the first video, when I explained tessellations, we talked about squares. And squares are an example of a regular tessellation. Okay. So what you're going to do is using the pattern blocks on that other link to make tessellations. And the link is also here, but I included it in the assignment that you can just click on like I did to open it. So you are going to use this to answer those questions. But the first thing you're going to do is you're going to make a sketch of 2 different regular tessellations in the space below. And then you're going to fill out the chart on the next page. And you're going to take a snapshot of your picture from the tessellation block and paste it here. So these are all regular polygons, and you want to figure out which ones tessellate. So what you're going to do, I'm just going to do the square because we already talked about it, is you click on, you drag the shape there. So you like click on it and drag, and then you are going to create or try to create a tessellation. And so what you're going to do is make sure that you at least cover all of one vertex. So this is a vertex, the point where they meet. I should have shapes all around at least, let's say 2 of those vertices. So to at least cover 2. And then you're going to take a snapshot of this and paste it into the Jamboard. So like I use the snipping tool, which your computer should have. If you just search like snipping, and then you can click like new and then highlight it and then go back to the Jamboard and paste it. So you have to paste 2 on here. Okay, so I do Control V on my computer. I don't know what it is for a Mac. So you're going to paste 2 different tessellations on this page. Okay. So what you're going to do is you're going to have to do more than 2 shapes because you are going to figure out which of these shapes tessellate. Okay, and so there's only 3 regular polygons that tessellate. We said a quadrilateral or a square does, and I'm going to explain how to fill this out. But what you're going to do is for, again, each shape, you are going, and you can hit the eraser button to delete all of them. You're going to figure out if they tessellate. So if I just do another one, I'll do the 11 gong since you guys don't have to do that one. And I'm going to see, okay, can I get this to tessellate? And this works pretty well that it attaches, like connects, but right here I have an issue. It just overlapped. Okay. And if I don't overlap, I can see there's definitely a gap here, and a dodecagon is not going to fit in this space. And so I can see using this pattern blocks, like, okay, a 11-sided, a dodecagon does not tessellate. And just to show you, because I'm not requiring for the 12, you can see if I do a decagon and try to connect it, okay, I cannot get it to tessellate the plane. I have a gap of this triangle. So this actually created like a semi-regular tessellation. If I add this triangle, you might have to rotate some of the shapes. So to do that, you click on this and it rotates it. But again, the decagon by itself does not tessellate. I have a gap of a triangle between them. So you're going to use this figure and you are going to do a triangle, a pentagon, a hexagon, a heptagon, an octagon, and see which ones can you get to tessellate. And then what you're going to do is you're going to fill out this chart. And this chart is to help you to see the pattern of how you can figure out if something tessellates or not. So you're going to fill in the number of sides. So I'm going to do the quadrilateral. So the quadrilateral, also known if it's a regular quadrilateral as a square, and that has 4 sides. Does it tessellate? We found yes. Okay. The measure of one interior angle. So one interior angle, if you remember from unit 1, is equal to n minus 2 times 180, the number of sides minus 2 times 180 divided by n. Okay, and so I'm going to do that here. I'm going to do 4 minus 2 times 180 and divide it by 4. And if we do this, we get 90. Right? And you should, most of you already know a square's angles are 90. So if you know what it is, you don't have to write the work. Okay. So then it says, if the polygon tessellates, how many polygons meet at each vertex? So you're going to go back to kind of your tessellation picture, and I deleted my squares. But I'm going to, again, put my squares and see how many meet at one vertex, or how many it takes to cover the plane. So if I look, here's my one vertex, and I need 4 to cover that vertex. And so in this part of my chart, I'm going to put 4. Okay, so that's how many polygons meet at a vertex. And then we're going to multiply column 3 by 4. So I'm going to do 90 times 4, which is 360. Okay. If it does not tessellate, you're going to leave this column blank. Okay, or you can put NA, non-applicable. Okay. So you're going to fill this out. Okay. And you should see like kind of a pattern with this of when it tessellates. Okay. And then the last part you're going to do is on the Jamboard. After you do that, the next page, and this is part of the packet as well, you're going to use the pattern blocks again on this tessellation applet to make a semi-regular tessellation using regular polygons. Okay, make a sketch of your semi-regular tessellation in the space below. If you're working in groups, and I have a little bit of typo there, but I'll fix groups, then each group member should come up with a different design. So if 3 of you are working together, there should be 3 different designs on this page. Each one came up with a different semi-regular tessellation. All the designs should be included here. Okay, so again, we talked about, I just did one before where I created a when I did the dodecagons, I realized once I put them together, I could fill in those gaps with another regular polygon, the triangle. Okay, and so this would be that picture. And again, you might have to rotate these. Fill in this picture to show a semi-regular tessellation. And then again, you're going to copy and paste this into your Jamboard for this page. So again, if you have three different group members, you're each going to need to come up with your own. And you should make sure that you're covering at least one vertex, preferably two when you're doing your semi-regular tessellation. Right. So that is the classwork activity. And again, you need to turn it in by Wednesday.